Hello, Algebra 1 students. We are checking our end of unit test practice. That means that we have our unit test coming up very shortly. And this unit test will be in two forms. So you're going to get half of the test on a piece of paper where you can use Desmos. That means you'll have your Chromebook open. If you don't have your Chromebook, then you'll take it without Desmos. All right, so bring your Chromebook. It's going to make it much easier. And then when you're done with that, you'll trade it for the part that you do without Desmos. So do that Desmos part first. You'll shut down your Chromebook, pack it away, turn in that first part of your test, trade it for the second part, and remember you can use a double-sided index card. So fill that in with with information, both sides. That would be helpful for all of this practice. All right, let's check these. I'm also going to talk through how you get these right answers. So check yours as we go. It does ask us to graph the following functions 1 through 3 on Desmos and use your graph to answer those following questions. So that would make sense to me because half of our test we can use Desmos on. Let me just pause that real quick. There we go. So a ball is thrown into the air. The equation h of t equals negative 16t squared plus 58t plus 6 represents the height of a ball after t seconds. All right, so we're going to have t for time in seconds. That's our input. Height of a ball in maybe feet. And so we're asking some questions about those things. Input, time, output, height. Let's go graph this on Desmos. So I'm on desmos.com. I go to the graphing calculator, and I'm just going to do this to see it a little more easily. All right, I need to type in my equation, so I'm clicking up here in this box, and I'm going to type in exactly what I see. H of t equals negative 16t, and to get the squared, I'm going to use this keyboard here. So let me just move myself down here. And I want to square it. So there's what I would do to square this graph. Now you see it instantly turned into a parabola, so I know I'm onto something perfect. So that gets that. Now I need to add 58t and add 6. So I just typed that into my equation. I'm going to hide this keyboard so I can see more of my screen. And I want to adjust it so I can see all the parts of this parabola. Right now I can see the y-intercepts, but I need to see up higher on the graph. So I'm going to use the wrench. I'm going to change my y-axis maximum because I want to see up taller on this graph. I don't want to see lower. I don't want to see left. I don't want to see right. I want to see something taller. So I'm going to start with 20, and it doesn't quite look like it's enough. I still can't see the top of that graph. So maybe 50. Oh, I'm getting closer. I'm going to go 80. And now I can see the top of that graph, so I think I'm in a great place. Okay. So when I click in certain areas, you see how it puts a point there, and I can see some different coordinates around my graph. So I'm going to use these values to answer these questions. What is a reasonable domain for this situation? So the first question is asking me domain. And since I'm looking at time across the bottom here and height here, negative time doesn't make sense for throwing a ball into the air. I don't go back in time. So my inputs, remember domain is asking about inputs, x values. Domain would start at 0, and it looks like it hits the ground here at 3.726. And so that is going to be my domain. So that's what I wrote down for a reasonable domain. 0, 3.726, and all of the x's in between. So I physically put x in between. T minus 5 is not part of this domain. This one only goes up to 3.726 seconds. 5 seconds doesn't make any sense. It means the ball has somehow gone underground. From what height is the ball thrown? Well, if we're talking about height and time, it is starting at that point right there. That's where it starts. And that's where t is 0. And so I need to go back to my graph and see when t is 0, it starts 6 feet off the ground. 6 feet. The maximum height of the ball, right here is the maximum. This is the path that the ball takes. So this is the highest high point that it gets to. So the maximum height, remember height is our output, y. So this ball is tossed 58.563 feet in the air. And when does that ball hit the ground? Well, that's when it has a height of 0. If it's 0 feet off the ground or inches or whatever this is, it happens at 3.726 seconds after it's thrown. So we have our height that it's thrown from, the maximum height of the ball, and when it hits the ground. Another ball is thrown in the air. This one follows a slightly different equation. And so I'm going to answer these questions when I look for this information. So I'm going back to Desmos. I'm just going to adjust my graph equation. So it has negative 16t squared plus 25t plus 5. And so there's my graph. Ooh, I can zoom in a little bit on this one. And now I see we have a different ball that's following a very different path. So let's start with a reasonable domain. Again, it doesn't make any sense for time to go backwards or be negative, so it starts at 0. And then it's going to land back on the ground here at 1.742 seconds. T equals 5 is still not part of this domain. It's not between those two numbers. 5 seconds is way over here off the graph. From what height is the ball thrown? That's when it is, when our time is 0, its starting height, and that is 5 feet off the ground. The maximum height of the ball up here, again, is our y coordinate, because that's our output, is height. So the maximum height of the ball is at 14.766 feet. It happens at this time, so that might be another question we might ask you. It happens 0.781 seconds after it's thrown in the air, so that's when it is at its highest point and helps us interpret it. When does that ball hit the ground? Right here again, height is 0, when time is 1.742 seconds. So here are my solutions for that part. I just wrote them all down as I was doing it. And we have our last one here. The function F gives the revenue in dollars that a business can expect to make if it sells this many magnets for this many dollars each. So it's good, first of all, to know how we find if it makes this many, and I multiply that by the number of dollars each, selling this many times this much money for each one is going to give me the equation for revenue. Okay, so this is important to remember now, that this is going to give us revenue. So if I have 17 magnets, for example, and I sell them for $3 each, 17 times 3 would tell me how much revenue I can make. Okay, so this one is an input of dollars price per magnet, and output is revenue, how much money they can make. So function F gives us the revenue in dollars. It asks a lot of questions too, and my instructions told me I could use Desmos on numbers 1 through 3. So I'm going to go to Desmos and type in my equation like this. Now, I don't have a fancy f of x or anything like that, so I'm just going to type it in exactly what I wrote on my paper. 240 minus 12x in parentheses times another x. And I see, again, I've got this start of a parabola, but I need to see some more different parts. So I'm going to go back to my wrench. I need to see higher up on my x values. Don't want that, go away. I guess it's going to keep on showing it to me. Anyway, I want to see higher up on my x values so I can see the other part of this graph where it comes back down. So if I put 20, I can barely see it on my screen there. I'm going to go ahead and put 25. That looks good. And I need to see higher up on the screen. So 100, oops, still can't see it. How about 1,000? Oh, I still can't see it at 1,000. I'm going to put in $1,500. I can see that vertex now. All right. So a little adjustment lets me see the entire vertex or the entire parabola. I need to find the vertex first. So when I click it up here, click that graph, it shows you where that vertex is. So it tells you a key point. So the vertex is an ordered pair, 10, 1,200. And then the question right next to that on my paper says, what does that tell us about the situation? So if my input is price, this tells me that at a price of $10 per magnet, $10 per magnet, my output is revenue, so the $1,200 is the maximum amount of money. So at the price of $10 per magnet, they make the most money. I'm going to just use that word maximum money of $1,200. So remember when you're doing interpretation like this, what does it tell us? We want to use the input and the output. We want to use the actual dollar amounts or whatever they are representing, and we're writing a sentence that interprets input and output. So the price of $10 per magnet will give them a maximum revenue of $1,200. What are the x-intercepts? What do they tell us about the situation? Okay, x-intercepts are happening where it crosses the x-axis. That's where y is 0. So I have two x-intercepts, one here when x is 0, one here when x is 20. And what that means in situation is that at 0 or $20 each, right? Those are our two inputs. In either case, they're making no revenue. They make no revenue. So it doesn't make sense for them to sell them at those prices. They're not going to make any money. If a school sells the magnets for $5 each, how much can they expect to earn? Okay, well, that's the price each, so that's an x coordinate. Okay, so I can do this one of two ways. I can plug 5 in for x into my equation up here. 240 minus 12 times 5 times another 5. So putting it in place of x. I can let Desmos do that calculation for me. So I'm going to just copy my previous equation, and I'm going to put 5 in place of x in both x's. So this is times 5, and I see that it gave me the total revenue of $900. Now another way to do that is to just click and hold on the graph, and you see how I can drag it back and forth and see what some different values are. And I want my x to be at 5, so if I follow this up to be at 5, it's kind of tricky, which is why I recommend just typing it in, but I can see that at $5 for a price, I make $900 revenue. All right. So to mimic our part of our test, I'm going to stop this video now. You should log off your Chromebook or log off Desmos and see if you can do the rest of this test without using Desmos or any graphing technology.